Welcome to this how-to video. In this video I will show you the installation of the standard process interface and the industrial process interface, and I will show you the setup of the industrial process interface regarding alarm recognition. With your delivery of the PI camera or XI400 camera, you received also a process interface cable which has a connector block, and this connector block has several input and output channels. You can also see that the connector block has several cables with colors. You can connect the standard process interface cable at the PI camera or XI400 camera direct next to the USB interface, and on the other end you have the connector block. Now let's have a look to the specification of the standard process interface. You can see that you have one analog input available and also one analog output and one digital input. It's important to know that you have to use an external power supply of 5 to 24 volt. As you can see here, that the connector block has several cables with several colors, and in the drawing you can see that each color has its own import or export function. You can also see the power supply cable as white and brown cable. What do we have for possibilities for input and output signals? You can use the process interface to forward temperature information and to change temperature information values, and you can also use the process interface for signal processing values. As you can see here, for the analog input channel, you can change emissivity values and you can also trigger external snapshots and recordings. Most of the analog input signals you can use also as digital input signals with a low and a high level signal. The analog output channel you can use for temperature information, and you can also use the analog output channel for signal processing, for example to forward the alarm recognition. Now let's have a look to our first test setup. You can see I'm using here the PI camera, and I connect the PI camera with the USB cable to the PC, and with a second interface at the PI camera I connect the standard process interface cable with the terminal block. You can see that I connect the terminal block with an external power supply, and I connect the terminal block with a multimeter, and I want to see here the voltage signal. On my table I have here the PI camera, and the PI camera is looking on the object which is heated up with the heating plate here. And at the PI camera you can see that I have here the process interface connection cable, and the process interface connection cable has a connection to my terminal block, and from the terminal block I have a connection to the multimeter. And you see also the external power supply at the terminal block. Now let's have a look to the software PixConnect. As you can see on the screen, I created here a measure area, and this temperature value of this measure area I want to forward via my process interface to the multimeter as voltage signal. How can we do this? You can go to the Setup menu, to the Configuration menu, and you go to the tab Device PIF. Now you can click on the button below to show all available ports we have. As you can see, we have one analog input, one digital input, and one analog output signal. I want to use the analog output signal to forward my process interface signal to the multimeter. So I click on the pull-down menu, and I'm choosing here measure area. Now I click on the button Setup, and here I'm choosing my measure area, which is area number 1. I defined now the minimum voltage output of 0 volt and the maximum output of 10 volt. So for 0 degree C, I have 0 volt. For 100 degrees C, I have 10 volt as output signal. Go to Apply and OK. Here you can also go to Apply and OK. Now I activate my multimeter screen on the display. And as you can see, I have now a voltage value of 6.89 volt. So this is exactly the temperature of my measure area, which is 69.1 degrees C. I can now move the object out, and you can see I have now a lower voltage signal, and I go back on my object, and you can see I have again 6.89 as voltage signal. Now let's have a look to the industrial process interface. With the industrial process interface, you can choose more in- and output channels, and you have an additional fail-safe relay. You have here also to use an external power supply of 5 to 24 volt. Let's have a look to the electronic box of the industrial process interface. As you can see on the top, we have the analog output channels on the left side, and we have the digital output channels on the right side. At the bottom, we have the analog input channels and also the digital input channel. You can also see that we have on the top, on the right side, the fail-safe signal where you can control a relay. Here we can see some examples how you can use the industrial process interface. As we have seen before, you can use the analog output channels to forward the temperature information, for example, to a multimeter. You can use the digital output signals to activate some actors as lights or acoustic signals. You can use the analog input signal to trigger a signal or for a reference temperature coming from a pyrometer, for example. And you can use the digital input for triggering snapshots. Let's start with the next test setup. As you can see, I have here again the PI camera. The PI camera is looking on my heated object. And at the PI camera, I'm using again the process interface. I have the process interface cable here, which is going to the electronic box of the PIF. And what you also can see is that I have here my external power supply. It's going into the electronic box. For my test setup, I installed here a red LED because I want to see an alarm recognition. Let's have a look to our PIX Connect software again. Now I have to do the setup for my test setup, and I go to the configuration menu, to the tab Device PIF, and here you can see that the industrial PIF is available. Now you can click on the button which shows you all available input and output channels. You can see with the industrial PIF that you have 2 input channels and 3 analog output channels. We are using for our test setup the analog output channel number 1. So I go to the pull-down menu and I'm choosing here Alarm. Go to the button Setup. And here you can see that we have no alarm with 0 milliamp and we have an alarm state with 20 milliamp. Go to Apply and OK. Now I go to the tab Alarm to define my alarm value. Here you can see my measure area 1. I define that I want to see temperatures as alarm if I have a temperature of 60 degrees C. I want to forward this alarm to my process interface, and I click here on this white shape to define on which channel I want to see my alarm recognition. I'm choosing the alarm output channel number 1. So I activate the item. I click on Apply and OK. Now we want to test the alarm situation with the software Pix Connect. As you can see, my measure area is now outside the object, and if I move now the measure area into the object, you can see immediately that the LED turns on. If I go out, the LED turns off, and I go now in, and you can see the LED turns on again, and I have my alarm because the object temperature is now more than 60 degrees C. If you have an interruption between your camera and your process interface box, or the software is not running, you have a failsafe signal at your process interface box. The failsafe signal will be shown with an LED, and you will have at the same time a signal which you can forward to your system. Now I will show you how to set up the failsafe signal with the software Pix Connect. Go to the configuration menu and to the tab Device PIF. Here at the bottom you can activate the failsafe. Go to the pull-down menu and activate this function. Go to Apply and OK. Now the failsafe function is activated and the LED of the failsafe turned on. I'm going now to disconnect the cable from the camera, and you can see immediately, if I disconnect, that the failsafe LED turns off. So this is a sign that you now have an interruption and you can forward the signal to your system. As we have seen before, you can use the process interface for a bidirectional communication to set values and to get temperature information and alarm states.